This lecture is about probability. We will discuss probability here. So, event A can occur in any ways out of a total of capital N possible and equally likely outcomes. The probability that event A will occur is given by Na by N. Quite a mouthful, don't worry, we'll walk it through an example. So the probability ranges between 0 and 1. It cannot be greater than 1. It cannot be less than 0. Simple example, head and tail are two equally possible outcomes in tossing a balanced coin. Therefore, probability of heads is half, probability of tails is half. In rolling a fair die once, there are 6 possible and equally likely outcomes 1, 2, 3, 4, 5 and 6. Therefore, rolling a 1 event is 1 by 6, 2 is 1 by 6, 3 is 1 by 6, 4 is 1 by 6, 5 is 1 by 6 and 6 is 1 by 6. So, probability of events. Two events A and B are not mutually exclusive if the occurrence of A does not prevent from happening, make impossible the occurrence of B or vice versa, then PA union B is equal to PA plus PB minus PA and P. Okay. Two events are mutually exclusive if the occurrence of A does preclude the occurrence of B or vice versa, then P union B is equal to PA plus PB because P and B is equal to 0. The rule of multiplication for dependent events. Two events are dependent if the occurrence of one is connected in some way with the occurrence of other. Then the joint probability of A and B is given by P and B is equal to probability of A into probability of event B given that event A has already occurred. So here's the thing. This is very important. I will repeat once again. The probability of event B given that event A has already occurred. We will walk through an example so as to make it more clear. Two events are independent if the occurrence of A is not connected in any way to the occurrence of B, then PA and B is equal to PA star PB. On a single toss of die, we can only get one of the 6 possible outcomes. 1, 2, 3, 4, 5 or 6. These are mutually exclusive events. If the die is fair, P of 1 is equal to P of 2, P of 3, P of 4, P of 5, P of 6 equal to half. The probability of 2 or a 3 on a single toss of the die is P of 2 is 1 by 6, P of 3 is 1 by 6, P2 or 3 is 1 by 6 plus 1 by 6. P2 or 3 or 4 is 1 by 6 plus 1 by 6 plus 1 by 6. An urn contains 10 balls that are exactly alike except that 5 are red, 3 are blue and 2 are green. What is the probability that picking up a single ball, the ball is red, blue, green, non-blue, non-green, green or non-green? What are the odds of picking a blue ball? What are the odds of not picking a blue ball? P of red is equal to 5 by 10. P of blue is 3 by 10. P of green is 2 by 10. P of non-blue is 1 minus P of blue is equal to 1 minus 3 by 10, 7 by 10. P of non-green is P minus P of green is equal to 1 minus 2 by 10 is equal to 8 by 10. And P of green or non-green is 1. The odds of picking up blue ball are given by the ratio of the number of ways of picking a blue ball to the number of ways of not picking a blue ball. Since there are 3 blue balls and 7 non-blue balls, the odds in favor of picking a blue ball are 3 to 7 or 3 to 7. The odds of not picking a blue ball are 7 to 3 or 7 is to 3. What is the probability of obtaining 2 red balls from the urn in the previous problem in 2 picks without replacement? P of red is 5 by 10. P red again without replacement is 4 by 9 because one ball's gone and you have already picked a red ball, so 4 by 9. So P of 2 red balls from the urn in the previous problem in 2 picks without a replacement is 5 by 10 star 4 by 9 is equal to 20 by 90 is equal to 2 by 9. What is the probability of obtaining 3 red balls from the urn in the previous problem in 3 picks without replacement? P of red is 5 by 10. P of red again without replacement is 4 by 9 because we have already picked one ball and there is one ball less, 4 by 9. P of red again without replacement is 3 by 8. And here P of it should be 3 red balls. 3 red balls from the urn in the previous problem in 3 picks without replacement is 5 by 10 star 4 by 9 star 3 by 8. 5 by 10 star 4 by 9 star 3 by 8 is equal to 1 by 12. Because it is without replacement, so there is, you see, one ball is getting reduced and the red balls are also getting reduced. Okay, let's end this at this point, and then what we will do is that we will go into another problem in the next lecture. I think this is quite a lot of information, so we'll stop here. Thank you so much. Bye.